Hi everyone. Today we will discuss about Greibach Normal Form. This is one normal form which is slightly different from CNF in terms of its representation and how the predictions are written. So we have these two standard normal forms. One is CNF, which we have discussed previously. In a CNF or Chomsky normal form, a non-terminal can be either two continuous non-terminals or a non-terminal can be a single terminal. GNF, we can say that if a non-terminal can determine a single terminal followed by alpha, this alpha is nothing but collection of non-terminals. Okay, so if the grammar prediction is of this form, then we say that the given grammar is in Greibach normal form. So as you can see, a context-free grammar G is said to be in Greibach normal form if all its predictions are of the form A can be small a followed by this alpha. So this A is the non-terminal, small a is a single terminal, and alpha can be 0 or more non-terminals or 0 or more variables. That is, A is a single terminal and alpha can be 0 or more variables. So as an example, I can have A can be small a is in GNF. A can be small a followed by capital B. It is in GNF. And also A can be small a, capital B, capital C. Okay, so a single non-terminal should be present at the first, followed by it can have any number of non-terminals. Okay, and also the grammar should not have any useless symbol. So the steps here we will see is the grammar should be in a simplified form as we have seen it in a Chomsky normal form. Okay, so for a grammar to be in a simplified form, it should be free from epsilon productions. If so, you have to eliminate. It should be free from unit productions, useless symbols. Under useless symbols, you have non-generating and non-reachable, and then you will get a simplified grammar. Now, this step of simplification of grammar is common for both Chomsky normal form and the Greibach normal form. Okay, and after this, what we are going to do is we are going to introduce some new non-terminals for those terminals that do not occur on the first character on the RHS. Okay, and replace the terminals with the corresponding non-terminals except for the first terminal. So ignoring the first terminal, we will replace all other terminals with some new non-terminals. So it depends on what grammar and what productions you have. Okay, and then you have to introduce some ordering among the non-terminals. You will have the variable named as S, A, B, M, and O, P, and so on. Okay, so for this, you can introduce some new ordering like A1, 8, 1 to 3. 1, 2, 3, 4, 5, 6. Likewise, if your production is S can be AB, S I can give the name as 1 or A1. A can be given the name 2 or A2. So like that, I'm going to give some ordering for this non-terminals. Okay, so this is the next step. And for each of these predictions that we have obtained after the ordering, I have to check the LHS and RHS value. LHS index value and the RHS first non-terminals index value. Always it has to be the case that I should be less than or equal to J. Okay, if it is not, then you have to do some. Okay. When you are doing the substitution, you substitute only for the first non-terminal that appears on the RHS of the prediction. Okay, if suppose the index value of I and j are equal, then we say a left recursion has occurred. Okay, that is in the LHS also you have the same variable and in the RHS also you have the same variable. Then you say that a left recursion has occurred and your grammar should be free from this left recursion. So you have to eliminate this left recursion, and the rule is if we have predictions like A can be A into something or A into something. So all these are the productions in which you have the same A repeated at the first. So this we call it as a left recursion. Why it is left recursion is when you try to construct a context-free grammar, we'll have A can be A into some alpha. Again this A will have some A into alpha. It will be skewed to the left side. Okay, therefore we say it is a left recursion. So and these beta terms are those productions which are not left recursion. Okay, how we are going to change is you're going to introduce some new non-terminal called as Z. Okay, so this part which does not have the left recursion is placed first, followed by those part which does not have Z, do not have the left recursion, but each of these are followed by a new non-terminal Z. What will be this Z is that this alpha component, alpha 1, alpha 2 up to alpha n, and this alpha is also followed by Z. So this is how we eliminate the left recursion. You will not have the same variable repeated here at first of the RHS of each of the predictions. Okay. So if suppose we have any left recursions, this has to be eliminated. Not all the grammars will have left recursion. If you have left recursion, it has to be eliminated. Now, all the AN predictions, we have numbered the non-terminals from A1, A2, A3 up to AN. After this elimination of left recursion, all the AN predictions will be in the Greibach normal form. Okay, this has to be substituted to AN minus 1, and this process will be repeated up to A1. Okay, and then finally the Z predictions should also be substituted, and then all the grammar's predictions will be in the JNF form. Let us understand this conversion into JNF with an example. So given a grammar, the first step is the grammar should be in a simplified form. So the grammar does not have any epsilon productions. Okay, there is no epsilon productions. So there are no nullable symbols. So you will write it as there is null nullable symbols, and the resultant grammar will be the same as the given grammar. Okay, and then we can proceed to the next step, which is elimination of the same grammar is present. Second step in the process of simplification of grammar is elimination of unit productions. So you have to identify the unit pairs. Here we have S comma A is a unit pair, and also S comma B is a unit pair. Yes, A and B. Okay, so now instead of A, I have to substitute all the productions of A. Instead of B, I have to substitute all the productions of B. So the S production will change as ABA or AB or BA or AA. And in addition to that, for A, I will have these two productions. For B, I will have these two productions. Yes, so you can write it in the same line with a separator. Since there is no space, I have written it separately, and the original productions of A and B will be as it is. Okay. The third step is elimination of useless symbols, and among these you have to find which are the non-generating and non-reachable. So S is generating, yeah, it has only it can generate terminal symbols. That is, you have directly A and B. What about A? A also has terminal, B also has terminal. So we have no non-generating symbols here. So the resultant grammar will be C. There is no change. What about non-reachable from the remaining? S from S, A and B are reachable, and there are no more non-terminals. Therefore, there are no non-reachable symbols. Okay, so this will be the final grammar will be. Now, this is the resultant grammar, and with which we are going to further proceed on the steps in JNF. So now we can see that yes, so all these productions, this A productions, all these A productions and these B productions, they are already in the JNF form. which is a single terminal followed by a non-terminal. One or it can be zero or more non-terminals. Here it is a single terminal. Here also it is a single terminal. Yes, A is a single terminal, and here S can be B is a single terminal. Okay, and what about all these? These are not in JNF. Okay, because the first thing that you should have in the RHS production is a single terminal. So what we can do is, since A is already in GNF, here also since A is already in GNF, here B is already in GNF, and A is also already in GNF. So we have to do the substitutions. With only substitutions we can achieve the GNF format. For this example is concerned. Okay, so yes, all the A and B productions are in GNF. All S productions have A and B as the starting symbol. So hence, for A and B, we substitute the productions of A and B. So with this grammar, which is simplified, we are going to do the substitutions. In this grammar, all these productions are already in GNF. Okay, so the remaining productions, which is for S, we have these 4 productions, right? These 4 should be converted to GNF form. Okay. Yeah, just erase. Now what we do is we just substitute for the first thing, that is first character, or for this A I'm going to substitute the productions. For this first A alone I'm going to substitute the productions of A. For this B I will substitute the productions of B, and for this A I will substitute the productions of A. So as simple as that we will substitute, and when we after substitution we will get the resultant grammar is in a GNF form, because we are going to substitute the productions which are in GNF form. These are A and B are already in GNF form. So after substitution, this also becomes a GNF form. So we can see it one by one. When we take this ABA, for A, I will have 2 productions, AA and A. So I have to substitute for this AA, and I will get BA. So AABA is the first thing. And for this A, I can substitute A. So I'll get small a BA, which is the second one. And then for this AB, I'll substitute AA and then B, the third production. And for this AB, when I substitute A, I'll get AB. So similarly, we have completed now this, and then similarly for BA and also for AA, I have to repeat the same process, and you will get this. Okay, so now we can say all these productions are in GNF form. Now we can start to write the remaining productions of S, which is already in GNF form, and also the productions of A and B, which is in GNF form. So when you see the S production has one production called as A, small a, capital A, which we have arrived here during the substitution. So you do not repeat this again for S. So you can either remove it here or you can either remove it here. Yes, so therefore I'll have again A or BB or B. And what about A? A will be the same, B will also be the same. So now all these productions of S, A and B, they are in the GNF form. We will look into one more example for the GNF conversion, in which some left recursions are also involved. So it doesn't, as of this example is concerned, it does not yield you the GNF with some simple substitutions alone. You need to do the ordering, and you need to eliminate left recursion. So I have chosen this example for that purpose. Okay, so here you are given a grammar with all these 5 predictions. For S you have 1 prediction, for A you have 2, and for B you have 2 predictions. Okay, in this grammar there is no epsilon predictions. Yes, yeah, there are no unit predictions, and there are no non-generating simples. S does not generate directly But instead of A and B, if I substitute small a and small b, I can yield a collection of terminals. So S is also generating, A is generating directly, B is also generating. And from S, A and B are reachable. So therefore, the grammar, given grammar is already in a simplified form. There are no epsilon units. Okay, so here the first statement given is the given CFG is already simplified and we don't need to further simplify it. Okay, now we have to check among the given productions, which productions are already in GNF. So A can be A is in GNF, B can be B is in GNF, and all these productions are not in GNF. They are actually in a CNF format. Yes, in CNF we have a non-terminal can be two non-terminals. A non-terminal can be a single terminal. Okay, so here by direct substitution you cannot arrive at a GNF form. What we do is give some ordering to the non-terminals which are present in the grammar. Since S is a starting simple, we give the name as we give the ordering as A1, and then followed by A. Since S determines A, I'm giving the name as A2. Since A is followed by B, I'm giving the name as A3. Okay, and therefore the rename predictions will be for S can be AB, it is A1 can be A2, A3. For A can be BS, it will be A2 can be A3, A1 or A. And for this B can be SA, it will be B. For B, I will write it as A3. A3 can be A1, A2 or B. Okay, so this will be the final grammar with which I am going to further proceed on the working of GNF. Now, you have the rename predictions here. Now you have to check for the values of I and J. For this prediction, A1 determines A to A3, I is 1 and J is 2. So I will check if I is less than or equal to J. For the first one, 1 is less than or equal to 2, yes, condition is true. And for the second one, 2 is less than 3, yes, it is true. And A2 can be A, it is already in GNF, we don't need to check anything. And what about this A3 can be B, it is already in GNF, we don't need to check anything. And this prediction A3 can be A1, I is 3 and J is 1. 3 is less than or equal to 1, the condition is not true. So what we do for A1 alone, we substitute the predictions of A1. So if I substitute the predictions of A1, A1 has only one prediction. So this A for A1 I substitute A to A3. So this A3 prediction will change as A3 can be A2, A3, A2. Now again I check for the values of I and J. 3 is less than or equal to 2. Again the condition is false. So now instead of A2 alone, I have to substitute the productions of A2. So A2 for A2, how many productions we have? We have A2 can be A3, A1 and A2 can be 2. So all these two productions must be substituted here. So therefore A3 will have after substitution two productions. So now I have repeated this A3 productions. You have only one production in which the format is not in GNF. Okay, and A2 has these predictions A3, A1 or A. We have one more prediction for A3 which is B. Okay, so since it is already in GNF, we have not repeated it here. And for this A2 alone, we substitute these two predictions. So A3 will have two predictions after substitution and its own prediction B. So on the whole, after the entire thing, we'll have three predictions for A3 as after this step is concerned. Okay, so when I substitute for A2, I'll get A3, A1 and then A3, A2. Yes, and also This A, if I substitute, I will get A and then followed by this A3, A2. And this B is the original production which is in GNF. So we have not made any substitution here. We have just placed it as such. Okay, now when you see these productions A, A3, A2, a terminal followed by non-terminals. This is a single terminal. These both are in GNF format. And here A3 can be this A3 into something. So you have this LHS and RHS first term. They both are equal. And so therefore we say this is a left recursion. And this part, to eliminate left recursion, this part, that is leaving this A3 part, we consider it as the alpha part. And all these will be beta 1, this will be, B will be beta 2. Yes. So now, since the left recursions occurred, we have to eliminate that. And now the production changes to A3 can be this part, A3, A2, sorry, A3, A2, and then this term should be followed by Z. So same A3, A2 with the Z, and then B with the Z. And what will be the Z? Z will be this alpha or alpha Z. So Z will be A1, A3, A2 or A1, A3, A2, Z. Okay, so now when you see after elimination of left recursion, all the A3 productions will be in the GNF form, a single terminal followed by non-terminals. Okay, now this A3 must be substituted in A2 part. So when you are doing the substitution, you have to be very careful not to miss out any productions and also not to miss out any variables. Okay, so now that all the A3 productions are in GNF, you are going to substitute in this A2 production. A2 production, this is already in GNF. Yes, for this A3 alone, I am going to do the substitution. So A3 has 1, 2, 3 and 4 productions. So when I substitute here, the single production will get splitted into 4 different productions plus its own production, this A, and on the whole it will have 5 productions for A2. So when I substitute A3, 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 A2 followed by A1 and A3, A2, Z followed by A1 and B, A1, B is at A1 and this is the A we have written as it is because it is already in GNF. So now all the A2 productions are in GNF. This A2 must be substituted in A1. Yes. So after substituting in A1, you will have, so the same process of substitutions only. So you will get this result after substituting in A1. Now since all the productions are in GNF for A3, A2 and A1. Now the only non-terminal which is remaining and unleft, it is which is not yet changed to GNF is the Z productions. Yes. Now you will substitute for Z. What is the starting variable? This A1. We have already A1 which is in GNF form. So therefore, this can be now substituted for the first term here and then which will make all the Z productions to be in GNF. So for this we'll have how many productions on the whole? When I substitute for A1, 1, 2, 3, 4 and 5 productions for this first term and for this production we'll have again the same substitution. So again 5 productions. So on the whole Z will have 10 productions. Okay, so just you have to do the substitution A3, A2, A1, A3 followed by this A3, A1, A3, A2 part. Similarly, you will have for the productions with Z at the end. Okay, so all these they deal only with the substitutions. And the final grammar will be what are the A1 productions, what are the A2 productions and A3 productions, and then the Z productions. Okay, So we have seen two examples in which the first example you arrived at the GNF with only direct substitutions. And the second example, we have arrived at the GNF by introducing ordering among the non-terminals, and also when you check for the I and j values, you had left recursion, and to eliminate left recursion, you had to introduce a new non-terminal, and you follow the ordering, and then by ordering you choose the AN first. This AN should be converted to GNF. It will be automatically converted to GNF, followed by AN minus 1, AN minus 2 up to A1. And finally, the Z protections will also be converted to GNF. Okay. Thank you.